Good day everyone. Today we are going to discuss class 8th science chapter number 6 combustion and flame. This is the part 1 video in which we will discuss about the combustion. We use different kinds of fuel for various purposes at home, in industry and for running automobiles. Can you name a few fuels used in our homes? Yes. Earlier days we were using cow dung cakes for preparing food, and also earlier days if we are preparing the food into the kerosene by the kerosene in the by using stove, we were using kerosene as the fuel. But nowadays at our homes for cooking food we are using LPG gas cylinders, liquid petroleum gas. Name a few fuels used in trade and industry. In the trade and industry, generally we use wood, coal, charcoal as the fuel. What fuels are used for running automobiles? For running the automobiles, generally we use diesel, petrol and CNG. CNG means compressed natural gas. Your list will contain fuels like cow dung, wood, coal, charcoal, petrol, diesel, compressed natural gas, CNG, etc. You are familiar with the burning of a candle. What is the difference between the burning of a candle and the burning of a fuel like coal? Yes, you can observe, if you will compare the burning of a candle and a coal, you will find that the candle burns with the flame while coal did not burns with the flame. So maybe you were able to guess right. Candle burns with a flame whereas coal does not. Similarly, you will find many other materials burning without a flame. Likewise, diesel, petrol, CNG are the fuels which are burned in the automobiles, but they are not burning with the fuel. They are giving the energy, but they are not giving the flame. Similarly, let us study the chemical process of burning and the types of flame produced during this process. So here in this chapter we will study about the chemical process of burning and types of flame produced during this process. What is combustion? Recall the activity of burning of magnesium ribbon performed in class 7th. We have studied about the burning of magnesium ribbon in class 7th. We learned that magnesium burns to form magnesium oxide, formula is MgO, and produces heat and light. So when the magnesium ribbon was burned, it produces heat and light, and it burns with the flame. In this picture you can observe the burning of magnesium, in which magnesium ribbon is held by a tongue, and when it is burned it gives heat and light, and also it turns into the magnesium oxide, which is a white powdery ash. We can perform a similar activity with a piece of charcoal. Hold the piece with a pair of tongs and bring it near the flame of a candle or a Bunsen burner. What do you observe? We will observe here that charcoal also burns in air. We know that charcoal will also burns in air and produces carbon dioxide, heat and light. So generally whenever the things are burning, they are producing heat and light, and also emits some of the gases like carbon dioxide or carbon monoxide. So here we can give the definition of combustion. A chemical process in which a substance reacts with oxygen to give off heat is called combustion. So the first condition is it reacts with oxygen, and second is it give off heat and sometimes light also. The substances that undergoes combustion is said to be combustible, or we can also say it fuel. So here in the previous example, magnesium, coal, charcoal, these are the combustible substance, or we can say these are the fuel. The fuel may be solid, liquid or gas. For example, solid is coal, is the solid, which is a fuel which is solid. Liquid, for example, kerosene is a kerosene, diesel, petrol are the fuel and they are liquid in form. And in the gaseous form, LPG, CNG, they are the fuel which are found in the gaseous form. Sometimes light is also given off during combustion, either as a flame or as a glow. So, during the combustion, the substance which is fuel or combustible substance, it give off heat, but including with the heat, it also gives light. In the reactions mentioned above, magnesium and charcoal are combustible substances. Here, Bujo is saying, we were told that food is a fuel for our body. Is it or not? Yes. Food is also a fuel for our body because it is giving us energy. Here, Paheli is answering to Bujo, rightly so. In our body, food is broken down by reaction with oxygen and heat is produced. We learned that in class 7th. So we can say yes, food is a fuel for our body because it combines with the oxygen and it produces heat and energy, and that energy is used by our body in our day-to-day works. Here it is an activity for you. Collect some materials like straw, matchsticks, kerosene oil, paper, iron nails, stone pieces, glass, etc. So, under the supervision of some elders, you have to try to burn each of these materials one by one. If combustion take place, mark the material combustible. Otherwise, mark it non-combustible. So here, the table 6.1 is for writing combustible and non-combustible substances. In first column, material is given. Second column, it is combustible, and third column, if it is non-combustible, we will mark a tick. First is wood. Wood is a combustible substance. Second is paper. Paper is also a combustible substance. Third is iron nail. If we burn the iron nail, it will not burn. So, it is a non-combustible substance. Kerosene oil, it is also a combustible substance. Stone piece is non-combustible substance. Straw can also be combustible substance. Charcoal is also combustible substance. Matchsticks also combustible. Glass is a non-combustible substance. So here, by this activity, we can conclude that all the things finding in our surrounding are not combustible substances. Only few things are combustible substances which react with the oxygen and burns and produces heat and light, and that are called combustible substances or fuel. Now, one more activity is there for understanding the combustion, that is, fix a lighted candle on a table, put a glass chimney over the candle and rest it on a few wooden blocks in such a way that air can enter the chimney, as we can see in the figure A, figure 6.2a. Observe what happens to the flame, and it is getting the air, so we will observe that it is burning. Now next is, now remove the blocks and let the chimney rest on the table. So it will also, downside, if we will remove the blocks, then it will not burn, and candle will stop burning. Then in the third condition, again observe the flame. Finally put a glass plate over the chimney, as shown in figure 6.2c. Watch the flame again. What happens in the three cases? Does the flame flicker off? Does it flicker and give smoke? Yes, it flicker and give smoke. Does it burn unaffected? Yes, in the figure 6.2a, it burns unaffected. Can you infer anything at all about the role played by air in the process of burning? Yes, we find that for the combustion here, air is necessary. At the situation A, 6.2a, the flame is getting proper air, because downside the wooden blocks are there, and by the wooden blocks it is getting the air and it is easily burning. The candle burns freely in case A, when air can enter the chimney from below. In case B, when air does not enter the chimney from below, the flame flickers and produces smoke. In case C, the flame finally goes off because the air is not available in case C. So here we can conclude that air is necessary for burning. If the combustible substance or fuel is not getting the air, and in the air oxygen, if it is not getting the oxygen, it will not burn. Now Bujo is asking, we have read that the sun produces its own heat and light. It is also some kind of combustion. Yes, it is also a kind of combustion. There is also going on the combustion nuclear reaction at the sun, and that's why it is producing a heat and light. In the sun, heat and light are produced by nuclear reaction. We will learn about this process in the higher classes. Here one next activity is for you. Activity 6.3. Place a piece of burning wood or charcoal on an iron plate or tawa. Cover it with a glass jar or a tumbler or a transparent plastic jar. Observe what happens. Does charcoal stop burning after some time? Yes, after some time, when the air inside the tumbler have been used for burning and now oxygen is not available for the charcoal, it will stop burning. Can you think of the reason why it stops? Yes, we can think because the charcoal now it is not getting the air for burning, and that's why it stops burning. So we can conclude by this activity that air is essential, oxygen is essential for burning. In our daily life, you might have heard that when the clothes of a person catch fire, the person is covered with a blanket to extinguish fire. Can you guess why? Yes, because when we wrap the person into the blanket, this blanket cut the contact of the fire with the environmental oxygen, and that's why the fire will extinguish. That's why it is wrapped by a blanket. Does a matchstick burn by itself? How does it burn? No, matchstick does not burn itself. When we rub the matchstick with the paper given with the packet, then the friction is producing the heat. Because of the friction, there is the production of heat, and because of that heat, the matchstick start burning. So you must have had an experience of burning a piece of paper. Does it burn when a burning matchstick is brought near it? Yes, when we bring a piece of paper with near the burning matchstick, it start burning. Can you burn a piece of wood by bringing a lighted matchstick near it? No, it will not be easy to burn a piece of wood with a lighted matchstick. We have to put kerosene or something other substance which will help the piece of wood to burn. Then only it will burn. Why do you have to use paper or kerosene oil to start fire in wood or coal? Have you heard of forest fire? This is the picture of forest fire. During extreme heat of summer, at some places dry grass catches fire. From the grass it spreads to trees, and very soon the whole forest is on fire. It is very difficult to control such fires. So, by the experiences of burning of matchstick, burning of a piece of paper, and burning of a wood and forest fire, by these experiences we can tell that different substances catches fire at different temperatures. So the different substances, they all the substances are not burning at the same temperature. Different substances have to catch fire at different temperature. So here that particular temperature is called ignition temperature of the substance. So here the lowest temperature at which a substance catches fire is called its ignition temperature. वो मिनिमम टेम्परेचर जिस पर कोई सब्सटेंस आग पकड़ता है या जलने लगता है, दैट टेम्परेचर इज कॉल्ड इट्स इग्निशन टेम्परेचर. वो टेम्परेचर उस सब्सटेंस का इग्निशन टेम्परेचर कहलाता है. Can you tell now why a matchstick does not catch fire for its own at room temperature? Yes, at the room temperature it is not getting the particular ignition temperature. That's why it is not burning. When we rub it with the paper, then its temperature will increase because of the friction. Heat is produced and this heat increases the temperature, and this increased temperature, now the matchstick found the ignition temperature and it starts burning. Why does the matchstick start burning on rubbing it on the side of the matchbox? Because it get the ignition temperature. Now here we should also know the history of the matchstick. The history of matchstick is very old, more than 5000 years ago. Small pieces of pine wood dipped in sulfur were used as matches in ancient Egypt. The modern safety match was developed only about 200 years ago. A mixture of antimony trisulfide, potassium chloride and white phosphorus with some glue and starch are applied on the head of a match made of suitable wood. When struck against a rough surface, white phosphorus got ignited due to the heat of friction. This started the combustion of the match. However, white phosphorus proved to be dangerous both for the workers involved in the manufacturing of matches and for the users. These days, the head of the safety match contains only antimony trisulfide and potassium chlorate. The rubbing surface has powdered glass and a little red phosphorus, which is much less dangerous as compared to the white phosphorus. When the match is strict against the rubbing surface, some red phosphorus gets converted into white phosphorus. This immediately reacts with the potassium chlorate in the matchstick head to produce enough heat to ignite antimony trisulfide and start the combustion. That a combustible substance cannot catch fire or burn as long as its temperature is lower than its ignition temperature. तो जब तक combustible substance को अपना एक पर्टिकुलर इग्निशन टेम्परेचर नहीं मिल जाता तब तक वो सब्सटेंस आग नहीं पकड़ता है. So the next thing which is necessary for burning, that is ignition temperature. One thing we observed that the oxygen or air is necessary for burning, and the next thing is the ignition temperature is necessary for burning, and the most necessary thing is the fuel or combustible substance should be there, air should be there, and ignition temperature should be there. Then only it will catches fire. Have you ever seen cooking oil catching fire when a frying pan is kept for long on a burning stove? Yes, sometimes if you will observe it at the kitchens, you will find that sometimes the cooking oil catches fire if we kept it for the long time burning stove. Kerosene oil and wood do not catch fire on their own at room temperature. But if kerosene oil is heated a little, it will catch fire. But if wood is heated a little, it would still not catch fire. Does it mean that ignition temperature of kerosene oil is lower than that of wood, and that's why kerosene oil catches fire easily while the wood does not catches fire easily? Does it mean that we need to take special care in storing kerosene oil? Yes, we have to be careful for storing kerosene oil because it easily catches fire. The following activity shows that it is essential for a substance to reach ignition temperature. So here another activity is there in which we have to make two paper cups by folding a sheet of paper. Pour about 50 ml of water in one of the cup. Heat both the cups separately with a candle as shown in the figure. In the figure it is shown heating water in a paper cup. What do you observe? So here as we will heat them, we will find in one of the cup there is a water is there. What happens to the empty paper cup? That empty paper cup will catch fire and it will burn. But what happens to the paper cup with water? We will find that the paper cup with the water, that will not catch fire and it will not burn, because inside the water it will take the heat and it will increase the ignition temperature of the paper. Does water in this cup becomes hot? Yes, because whatever the heat we are giving to the paper cup, that is absorbed by the water, and paper is not getting the proper ignition temperature. That's why it will not burn while the water will become hot. If we continue heating the cup, we can even boil water in a paper cup. The heat supplied to the paper cup is transferred to water by conduction. So, in the presence of water, the ignition temperature of paper is not reached and hence it does not burn. So here now we can define inflammable substances. The substances which have very low ignition temperature and can easily catch fire with a flame are called inflammable substances. So for the examples of inflammable substances, we can say petrol, alcohol, liquefied petroleum gas, LPG, etc. are the inflammable substances. So here it is the points by which we can summarize the today's topic, combustion. The substance which burn in air are called combustible substances. Oxygen or air is essential for combustion. Next is during the process of combustion, heat and light are given out. Ignition temperature is the lowest temperature at which a combustible substance catches fire. And the last we studied about the inflammable substances have very low ignition temperature, likewise diesel, petrol, kerosene, etc. So students, I hope this video will be beneficial for you to understand the content of combustion. Share the video with your other classmates and friends and also subscribe my YouTube channel NCERT Science Mantra. Also press the bell icon so you will get the notification as I will upload my next video. Thanks for watching the video.